In the vast expanse of our solar system, Ceres stands apart as an object of intrigue and wonder. It holds a unique position, straddling the line between asteroids and dwarf planets. This dual citizenship makes Ceres a captivating subject of study, offering invaluable insights into the processes that shaped our cosmic neighborhood. Asteroids are rocky remnants from the early solar system, relics of a time when planets were still coalescing from a swirling disk of gas and dust. Dwarf planets, on the other hand, share characteristics with both planets and asteroids. Like planets, they are massive enough for their own gravity to mold them into nearly round shapes. Ceres' existence in this intriguing middle ground provides a crucial link between these two populations of celestial objects. By studying Ceres, we gain a deeper understanding of the diversity of objects that populate our solar system and the processes that led to their creation. The tale of Ceres begins on the first day of the 19th century. On January 1, 1801, Italian astronomer Giuseppe Piazzi aimed his telescope at the heavens, unaware that he was about to make a discovery that would forever alter our understanding of the cosmos. As he meticulously charted the positions of stars, a faint point of light, uncharted on any existing celestial map, caught his eye. Initially, Piazzi believed he had stumbled upon a new comet. However, as he continued to observe the object over the following nights, its movement revealed a curious behavior, one that set it apart from the predictable paths of known comets. Unlike these icy interlopers, the newfound object moved with a steady, almost stately pace, following a path that hinted at a more permanent residence within the solar system's inner sanctum. Calculations based on its observed motion suggested that it resided at a distance of roughly 2.8 astronomical units from the Sun, placing it squarely within the vast expanse between Mars and Jupiter. The discovery of Ceres in the heart of this predicted planetary gap sent ripples of excitement through the scientific community. Ceres was hailed as the eighth planet, taking its place alongside Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Uranus. However, this newfound planetary status was destined to be short-lived. As telescopes improved, a startling realization began to dawn. Ceres was not alone in its lonely vigil between Mars and Jupiter. Other, smaller objects, sharing similar orbital characteristics, were discovered in quick succession. This newfound understanding led to a dramatic shift in Ceres' classification. No longer the solitary guardian of the space between Mars and Jupiter, it was now recognized as the largest member of a vast and diverse population of objects known as asteroids. In 2006, the International Astronomical Union redefined the very definition of a planet, introducing a new category: dwarf planets. Ceres, with its diameter of approximately 940 kilometers, dwarfs its asteroid companions. It is the undisputed king of the asteroid belt, accounting for roughly one-third of the belt's total mass. Ceres' size has played a crucial role in its unique evolution. Its mass has endowed it with a gravitational pull strong enough to mold it into a nearly spherical shape. This characteristic sets Ceres apart from the majority of asteroids, which tend to be irregular in shape. Ceres' relatively large size also hints at a differentiated interior, a feature shared with larger planets but less common among smaller asteroids. This differentiation implies that Ceres' interior is not a homogeneous mixture of rock and ice but rather separated into distinct layers. This process, known as differentiation, is a fundamental stage in the evolution of planetary bodies, shaping their internal structure and influencing their long-term geological activity. Ceres, along with its countless asteroid companions, resides in the asteroid belt, a vast donut-shaped region located between the orbits of Mars and Jupiter. Ceres' orbit around the Sun is not perfectly circular but slightly elliptical, meaning its distance from the Sun varies slightly throughout its year. It takes Ceres approximately 4.6 Earth years to complete one orbit around the Sun. While Ceres' orbit is relatively stable, it is not immune to the gravitational nudges of its massive planetary neighbors, particularly Jupiter. Jupiter's immense gravity acts as a cosmic shepherd, shaping the asteroid belt's structure and influencing the orbits of its inhabitants. The gravitational interactions between Jupiter and the asteroid belt have prevented the formation of a planet in the region, leaving behind a scattered disk of rocky debris. Despite the gravitational jostling, Ceres' orbit is tilted at a relatively small angle compared to the plane of the solar system. For centuries, Ceres remained a tantalizing point of light, even through the most powerful telescopes. However, in 2015, humanity's gaze pierced the veil of distance, revealing Ceres in unprecedented detail. This remarkable feat was accomplished by NASA's Dawn spacecraft, a robotic explorer dispatched to unravel the secrets of the asteroid belt's two most massive residents, Vesta and Ceres. Dawn's mission to Ceres marked a new chapter in our exploration of the solar system. For the first time, a spacecraft had ventured into the asteroid belt, not merely to fly past its inhabitants, but to take up residence in orbit around one of these enigmatic worlds. Equipped with a suite of scientific instruments, Dawn embarked on a comprehensive survey of Ceres. One of Dawn's most significant discoveries was the presence of water ice on Ceres's surface. This discovery has profound implications for our understanding of the early solar system and the distribution of water, a key ingredient for life as we know it. As Dawn's cameras captured image after image of Ceres's surface, a world of unexpected diversity and complexity emerged. Far from being a barren and lifeless rock, Ceres revealed a landscape sculpted by a variety of geological processes. One of the most striking features of Ceres's surface is its abundance of craters, silent testaments to the relentless bombardment of asteroids and comets. These craters range in size from small, bowl-shaped depressions to vast impact basins hundreds of kilometers in diameter. Dawn's images also revealed towering mountains, vast plains, and intriguing networks of fractures and grooves. One of the most puzzling discoveries was the presence of bright spots, highly reflective areas that stood out against the dark, heavily cratered terrain. This finding further strengthened the case for Ceres harboring a significant amount of water ice, perhaps even a subsurface ocean. Ceres's unique characteristics, bridging the gap between asteroids and dwarf planets, make it a valuable point of comparison in our quest to understand the diversity of objects that populate our solar system. Its size, shape, and composition provide clues about the processes that governed the formation and evolution of these celestial bodies. Compared to its smaller asteroid siblings, Ceres stands apart as a giant, its nearly spherical shape and differentiated interior setting it apart from the irregularly shaped, undifferentiated bodies that dominate the asteroid belt. This difference in size and internal structure highlights the crucial role that mass plays in the evolution of celestial objects. When compared to other dwarf planets such as Pluto and Eris, Ceres's composition reveals intriguing differences. While Pluto and Eris are thought to be composed primarily of rock and ice, Ceres appears to be richer in rocky materials, with a substantial amount of water ice mixed in. This difference in composition likely reflects the different regions of the solar system in which these dwarf planets formed. The study of Ceres holds profound implications for our understanding of the solar system's formation and evolution. By piecing together the clues locked away in Ceres's composition, internal structure, and surface features, we gain a deeper appreciation for the intricate dance of gravity, heat, and chemistry that gave birth to the solar system we know today. Ceres's location in the asteroid belt provides valuable insights into the early solar system's chaotic environment. The gravitational influence of Jupiter prevented the material in this region from coalescing into a full-fledged planet, leaving behind a scattered disk of asteroids, with Ceres as its largest member. The presence of water ice on Ceres's surface and the possibility of a subsurface ocean raise intriguing questions about the early solar system's water distribution. Water is a key ingredient for life as we know it, and its presence on Ceres suggests that the building blocks of life may have been delivered to the inner solar system by asteroids and comets. Ceres's unique characteristics make it a potential target for future exploration, both robotic and, perhaps one day, human.